Hello, Kirk Edwards here from EXAIR Corporation. Today I want to talk to you about our line vac products, specifically the heavy duty line vac. Now, a line vac is a product used to move dry bulk materials from point A to point B. We manufacture a standard line vac, also a heavy duty line vac. We manufacture these in aluminum, stainless steel, 316 stainless steel with both smooth end connections and threaded end connections. NPT threads on these from 3/4 NPT up through 2-inch NPT, so that they can be used with both hose and tube or pipes. Now, a line vac generally behaves like a coupling between two sections of transfer hose or pipe. We've got a suction side and a positive pressure side or discharge. You will use your dry bulk material on the suction side. It'll suck it through the tube, move it up to 40 feet away, depending on the bulk density of your material. That's for a standard line vac. We're going to concentrate a little bit more on a heavy duty line vac today, which are specifically designed to move much heavier, much more abrasive materials over a longer distance. This product is made from the proprietary heavy duty line vac hardened alloy, also available in threaded or smooth ends. Here's a threaded end here. Heavy duty line vacs can move material up to 100 feet or more, also depending on the bulk density of the material. In today's video, I want to concentrate on our heavy duty line vac and its superior durability when used with abrasive materials. When we started to develop this product, we ended up concentrating on three main materials of construction. We use stainless steel, a hard-coated anodized aluminum, and the specialized hardened alloy, which ultimately was the material of choice. When we began to do the testing on all the different materials of construction, we put all these materials through the same standardized accelerated life cycle test. We ran different materials through the line vacs to determine the abrasive resistance of the material itself. These materials were walnut shells, ceramic tumbling media, steel tumbling media, and the most abrasive of all, ground glass. Let's look at these dry bulk materials with the stainless steel line vacs first. What we found with the stainless steel is that any metal material that's actually softer than the stainless steel itself worked out just fine. Also worked out very well with the walnut shells, and we didn't see any wear on the stainless steel. The more abrasive materials, beginning with the ceramic tumbling media and through the ground glass, did start to show wear on the stainless steel construction. Today, we recommend stainless steel for applications needing superior corrosion resistance, resistance to chemicals or extreme environmental conditions. We also recommend them for food, pharmaceutical, and medical applications. Here you can see that the stainless steel line vac is showing wear right at the exit of the compressed air. This is where the highest velocity and the hardest impact of the material against the wall of the line vac occurs. The hard coat anodized aluminum did well with the walnut shells, but moving on to any more abrasive materials, it began to fail. You can begin to see some wear at the discharge exit holes, and the internal coating, the internal hard anodized coating, is completely worn off and now exposing bare aluminum, which will continue to show wear with the ceramic tumbling media. Here's another interesting case. This is with the steel tumbling media. Again, the internal surface is banged up, the hard coat anodized is wore away, but another interesting thing happened with this line vac. On the return side of the testing, with the softer aluminum material, the heavy hard steel shot actually warped the softer aluminum material. That is quickly on its way to failing as well. So not only do we wear through the hard coat anodized, in this case we began to just warp and bulge that aluminum material. Much too soft for this application. And here is the wear on the ground glass with the hard coat anodized aluminum line vac, again showing those same grooves at the discharge of the compressed air, where we've got the highest velocity and the hardest impact upon the aluminum material of construction. It's also got some wear on what would be the intake side, or the return side of this test, or the intake side of the line vac, showing clearly wearing away the hard anodized surface and exposing the bare aluminum. Again, well on its way to wearing out and not giving you a very long life for an industrial product. So where do we end up? We end up with EXAIR's custom hardened alloy. It fared just fine with all four materials: the walnut shells, the ceramic tumbling media, the steel tumbling media, and the ground glass, showing no signs of wear whatsoever. This line vac showed no wear with all of the materials, and we continued to use this one individual line vac with all four materials. And just to recap what we've seen so far, here's the stainless steel line vac used with ground glass, showing wear at the outlet of the compressed air. The next three materials are the hard-coated anodized aluminum, ceramic tumbling media, steel tumbling media, and ground glass. Final version is the current EXAIR heavy-duty line vac, which was used with all four materials, showing no wear at all. This hardened alloy material construction is the key to a successful, durable, unfailing application when dealing with the most abrasive materials. Another benefit to the heavy-duty line vac is that it will deal with very heavy bulk densities of material and has a capacity to move these products farther than the standard line vacs. If you have any additional questions about heavy-duty line vacs or air-operated conveyors, if you have a bulk material application at your facility, please call EXAIR. We'd be happy to hear from you. Thank you.